Kohlrausch law. Okay. So there we have found that we can calculate the limiting molar conductivity of weak electrolytes by application of Kohlrausch law. So example that I have already given. Suppose you have to find out for lambda m0 for acetic acid. So what did you find? We can get it by this equation, that HCl plus sodium acetate minus NaC. That we have already done. Okay, now you do a numerical. It's already given. Do it for. It's very easy, son. না না এদিকে রুটি আছে those who did not do now we have to do the second one calculation of dissociation constant of weak electrolytes. Weak electrolytes does not undergo complete dissociation. Okay, so dissociation constant of weak electrolytes is we always call alpha. Okay. Okay. Now, what is alpha? Alpha is number of ions present in the solution because ions only conduct electricity. A number of ions supposed to be present. Suppose you have added 1 mole of a substance. 1 mole of substance should all the molecules should now break down to give you ions. But if you find it is 5%, means only 5% of the molecule has broken down into ions. The rest of them did not break. So a neutral molecule never conducts electricity. So here only the 5% ions will carry the electricity. And number of actual number of ions supposed to be present in the solution. So all the ions, when they on all the molecules undergo complete dissociation, the condition is it should be at infinite dilution. Okay. So in that case, okay, now you can write complete dissociation of weak electrolytes takes place only at infinite dilution. Okay. So what is the conductivity at infinite dilution? Conductivity at infinite dilution is called lambda m0 or lambda m infinity. All right. Now conductivity at any concentration, that is not 100% dissociation has written. So conductivity at any other concentration, that is not at infinite dilution. So what do you call it? Lambda mc. Therefore, alpha is equal to lambda mc by lambda.
Done, sir.
Now I have done a mistake. It's not a calculation of dissociation question. Consider a calculation of degree. Sorry. Calculation of this change there. This change. Degree of dissociation. Degree of, sorry, calculation of degree of dissociation. Not now, third will come. calculation of dissociation constant. Okay, see here. For a weak electrolyte, let us say acetic acid. We have taken acetic acid. It means what? It has not gone for complete dissociation. Complete dissociation, we give only one single error. So I'll write this one as CH3CO minus and H plus. Okay, let us see that C is the concentration. Okay. Now see here, and alpha is the degree of dissociation. I'll explain to you. Don't worry. So this is C alpha and this is C alpha. Okay. Now, let me make it more clear. See, weak electrolytes, lot like this strong electrolyte, moment you put it in water, it will break down. When you put, moment you put and check, you will find that it did not break. So I'll write now. Okay, I'll write here. I'll write now here. At 0 second, means moment you start, concentration is C alpha. This is 0, this is 0, because it takes some time to break them. Now I'll write now. At equilibrium means when dissociation has come to the stop. So in that case, you will find if alpha is the degree of dissociation, it will be C alpha and it will be C alpha. And this will be 1 minus. I'll tell you. Try to understand. Acetic acid undergoes 10% dissociation at room temperature. Suppose I have taken here, don't write. I have taken 100 molecules. Okay. Only 10 molecules break down. So 10 molecules, each molecule will give you acetate and H plus. So at equilibrium, only 10 molecules has dissociated. So how many will be there here? 10, this is 10, and this is 10. Because 10 molecule breaks, breaks into two parts. So if this is 10, this is also will be 10. Now how many are not being dissociated? See here, right now, 100 minus 10 is equal to 90. 90 molecules are remaining undissociated. All right. What is the degree of dissociation? Alpha. See, I have done alpha. So I'll find out. Is it equal to 10? See here. So alpha is equal to what? 10%. So what is C alpha? C alpha is equal to what? C is what? 100. And alpha is equal to what? 10%. So 10 divided by 100. How much it comes? 10. How many left out? See here. C 1 minus alpha. Is it 90 or no? See here. C into 1 minus. Well, right now here. 100. Now 1 minus 10 by 100. So it is 100. If I take 100 minus 10 divided by 100, how much it comes? 100 into 90 divided by 100. How much it comes? 90. See, is 90 or not? So because of that, I have written. So this portion you need not write. You understood. Right up to this. Now what is the degree? What is the dissociation constant? How do you find dissociation constant? K is equal to what? It is product of this and say this. So this one, moment you put in the square bracket means concentration. So concentration is already mentioned. This is what? C alpha. This is what? C alpha. Divided by what? C 1 minus alpha. So this is K. Therefore, this is K. Now what is alpha? Alpha you have already found. Alpha is MC by lambda. Therefore, K is equal to, this is equal to what? See, C and C can cancel. So is equal to C alpha square 1 minus alpha. So right now here C alpha square is what? MC by lambda M0 square. And this is 1 lambda MC by the conductivity of 0.001 will get 0 to 8 mole liter invert acetic acid is 4.95 into 10 to the power minus 3 with me. Let me check. Without specs, it's difficult for me. I will. This is 5, huh? This is S. S means Siemens. Calculate its dissociation constant. If lambda M0 for acetic acid is 390.5 Siemens centimeter square mole. So I'll give you the hint. What is the hint? We know K is equal to what? K is equal to C alpha square 1 minus alpha. Okay, this is this. Yes. No. Yeah, this is K. This is the equation. From here you have to suppose. But you do not know alpha. So what is alpha? Alpha is lambda C by lambda M0. See, lambda M0 is being given. Lambda MC is not being given. Now what is lambda MC? Lambda MC, you know, conductivity by kappa by C. Kappa is the conductivity. C. This is the conductivity. C is the concentration. So first you find this one, putting the value of this one. See, lambda m0 is being given. Then you find the value of alpha. After getting the value of alpha, put it here. Concentration is given. Find out the solution. All these things should you know. Do. What is your name?
Yes, sir.
What is your name?
Payal.
Huh?
Payal, sir.
Full name.
Payal Paul.
Okay. Good. Let others do it. Then 0.001028 mole liter inverse. If you can convert into ml, see it is liter. So this 1000 will go up. It will be 1000. It comes to 48.15 Siemens centimeter square mole inverse. Okay. So you have to put this one here. 48.15 divided by this value 390.5 Siemens centimeter square mole inverse. Siemens centimeter square mole inverse. This comes to 0.1233. So put this value and get it. This I will not do.
So why did you use 1000, sir?
Huh?
1000.
Because it is in liter, na. I have to convert in ml. So it is given liter. Application part of the electrochemistry. In your book, the way I have taught in your book, it is not given like this. In your book, first they have started with the electrochemical cell, then they have come to conductivity. This is an irony. Why? Because you do not know conductivity, then how do you know an electrochemical cell? Huh? If you do not plant paddy, can you get rice? Huh? you cannot get rice. First paddy comes, then the rice. So the chapter who has written, I have nothing to tell. I'm not saying that I'm more intelligent, but science is systematic. Okay. So we have found in electrochemistry, we read two things. One, to carry out non-spontaneous reaction with the help of electricity. It is conversion of electrical energy into chemical energy. And second one, to generate electricity from spontaneous redox reaction. That is conversion of chemical energy into electrical energy. So now we'll go for the use of electrical energy to bring about some reactions which normally do not occur under normal conditions. Okay. So we'll go for now electrolytic cell. I'll post this note, you read from there, but I'll just explain. What's in electrolyte? I have already drawn also for you. This is a container or a vessel which is made of insulated substances. So this can be a beaker, glass beaker, or it can be plastic, or if it is little costly, it can be made of Teflon, or it can be even made in a earthen pot. Okay, and here you will give two electrodes. Okay, it may be just like a rod, it can be just like a plate. So these are the two electrodes. Okay, and after that it is being filled with electrode. Now the electrolytes. By convention, we right hand side we write cathode, and left hand side we write. We know what is called cathode. The electrode to which the cations migrate. And migration of ions always takes place to the oppositely charged electrode. So cations carry positive charge, so it is a negative. And anode, anions migrate, so it has to be a positive. Okay. Now, what are electrodes? These are the metallic substances which conducts electricity. These are the metallic substances which conduct electricity. Now you have an exception. What is the exception? Graphite. Graphite is an allotrope of carbon. Carbon means what? Non-metal. But it also conducts electricity. Graphite is an allotrope of carbon which can also used as what? They, sorry, not they. It conducts electricity that you have learned in school. Electrodes are of two types. In your book, this is not being mentioned. are of passive electrode and active electrodes. Now, what is the passive electrode? They conduct they only conduct electricity and do not participate in in any reaction within cell. Or what you can say, or react with electrons. Example, graphite. Then platinum. Then rhodium. That's it. The active electrodes they not only conduct electricity but also participate in the reactions. Right, I'll give you the example. For example, most of the metals like what? Gold, silver, copper, nickel, chromium, etc. But except what? Platinum, rhodium. Okay, so let me complete. Now, these will be connected to batteries. This is Okay. And this you have a key. It is switch. We call it. If you switch it on, that electricity is going to flow. Okay. This is a negative band, and this is the positive. So this is the electrolytic. Wait, let me write. Let me change that. Here we will have an emitter. Then you know how much current is flowing. Electrolytics. Electrolytics. And electrolytic cell is an electrochemical cell in which an electric current devises a non-spontaneous. What is the symbol of non-spontaneous? Delta G is positive. Redox reaction. The process of producing a chemical change in an electrolyte by passing electricity in an electrolytic cell is called electrolysis. So let me write the definition of electrolysis again. We'll now we'll go to the electrolysis. See, electrolysis is a chemical change. The process of chemical decomposition of an electrolyte by passage of electricity through its aqueous. So that electrolyte conducts electricity either in a water solution or in molten state or in the molten state is called electrolysis. Or chemical changes occurring at electrodes when electric current is passed through an electrolyte present either in dissolved state. Means what? Aqueous solution or in the molten. I'll give an example. Sodium chloride. When I write L means it is in molten state. Electrolysis. So you get here now 2 sodium and Cl. How does it happen? Sodium chloride in molten state it ionizes. See, again by convention we are supposed to write the cathode first and anode. But I'll write the reaction of anode first. See here. This chloride. This chloride is an anion, so it will go to anode. Okay. After going to anode, it will lose one electron. So you'll get from chloride, you get chlorine element. We know that chlorine element, one atom of chlorine element is not stable. So two of them will join with each other because thousands and thousands are going. So you get here chlorine is a gas. This electron will come through the wire from anode to the cathode. And cathode who is waiting there? Sodium. Metal ions are cations are electron deficient. So it will take the electron, and it will become now sodium metal. Why do you write S? S stands, it is solid. So here I have written 2. So I'll write here now 2. So it will be 2, 2. This will be 2. It will be 2. So at cathode you will find sodium is depositing, and at anode what you will find, the chlorine gas is evolved. You can literally see the bubbles are coming out there. So up to this much is enough for today. I'll do it next Thursday.